All right, you guys, today we are looking at more trigonometry with some mixed review tied in. So let me zoom in just to get a little bit closer so you can see everything nice and big. All right, so for my very first problem, I'm saying find perimeter and area, simplify radicals. So that first triangle to the left, right, I recognize that this angle has to be a right angle as well. So that's a 45, 45, 90 triangle. And the one on the right is a 30, 60, 90 triangle. I only have one part that's marked, and it's marked as 12. So if I build off of this triangle, I know that opposite the 30 is the x, that's the short leg. Opposite the 60 is the x root 3, that's the longer leg, and opposite the right angle is the 2x, that's the hypotenuse. So if 12 is x root 3, I need to take a third of it and multiply by root 3. So I get 4 root 3 for that short leg, that's x. I double it to get to the hypotenuse, which is 8 root 3. So now I can look at the triangle on the left. So it's a 45, 45, 90 triangle, so the two legs are the same. So 4 root 3 right here. And then the hypotenuse, that's the x root 2. So if I take 4 root 3 and I multiply by root 2, I get 4 root 6. Okay, so now my perimeter, I'm looking at the total distance around my figure. So what I have marked here in yellow. So here for perimeter, if I add up all of those sides, I'm taking the 4 root 6, adding the 8 root 3, adding the 12, and the 4 root 3. So these are like terms right there. They're the only ones we have. So I can only consolidate the 8 root 3 and the 4 root 3. So right now I have 4 root 6 plus 12 root 3 and then plus 12. That is my perimeter. Any order that you write those would be perfectly fine. So 4 root 6 plus 12 root 3 plus 12 and then U for units. All right, next I need the area. So for my area, let me just swap out my purples, get a better purple. Okay. All right, so for area, I know it's 1/2 the base times the height. Area is 1/2 base times height. So my base is this full side right here, 4 root 3 plus 12. And then my height right here is 4 root 3. So I'm going to do 1/2 of 4 root 3 plus 12. That's my base, times my height, which is 4 root 3. So I can multiply whatever order I want. So I would probably take 1/2 of 4 root 3, so 2 root 3, and then I'm going to distribute over the 4 root 3 plus 12. So when I distribute here and here, first I have 2 root 3 times 4 root 3. That's like saying 2 times 4 times 3. That's 24. And then 2 root 3 times 12 is 24 root 3. So that's my area. Either order is fine. I'm going to write it as 24 plus 24 root 3, and my units are squared. All right, next skill right here. So here I'm saying find the value of x. Well, I have quite a few ways where I could get to x. We've learned several different methods. So let me catalog those 3 methods that could work. All right, so method 1, we can see that we have this big right triangle, and it subdivides into a smaller right triangle and then a third right triangle right here. It's kind of the medium-sized one. Okay, which means that this right here has to be the altitude of the big triangle. We know that the altitude divides it into smaller, similar right triangles. So I could treat this as a similar right triangle problem, which would be fine. Just to jog your memory, that's where we used the tick marks to help us better see how our corresponding parts aligned. Okay, a second method could be to go through area. I could go through area in two ways. So what I mean by that, right, I know that the area is 1/2 the base times the height. So in my triangle, I could use this as my base and this is my height. Again, 1/2 base times height would be area of a triangle. So once I know what my area is, well, I know that, well, if I call this the base and this the height, it should get me the same area. So I could build off my knowledge of area and get to X that way. A third way is really our current unit. We can use trigonometry. So I could use trigonometry to be able to get to X. All right, so let's say that I use trigonometry as my method because that is where we're at right now. So I want to show you how I can use that to connect the dots and get to X. So first thing that I would need is, well, I need an angle. I don't have any angles in my picture. I only know the right angles. I need an acute angle to help me connect the dots. So let's say that I visualize this large triangle right here. Let me draw it out so you can see it by itself. So I have this triangle right here where this is my right angle. I know that this is 15, this is 8, and this is 17. I know all of the sides. So let's say that I want to get to theta. I want this angle right here. Well, since I know all of my sides, I could use sine, cosine, or tangent. They would all work. Let's say that I use sine. Okay, so I'm viewing this as my opposite and this as my hypotenuse. So I should note that sine theta gets me that ratio of 8 to 17. So then the inverse of sine with that ratio gets me my angle measure theta. So when I type that into my calculator, I get that theta is about 28.0725. So that angle is this angle right here. That is this angle right here. So now keep in mind, I'm trying to get to X. So now let's say that I visualize this right triangle right here. Let me draw it out a little bit bigger like that. So again, I know this angle now. I just solved for it. It's about 28.0725. Okay, and I know that this is X and this is 15. So with my reference angle right here, I have an opposite and a hypotenuse. So I'm going to use sine again. I know that sine 28.0725 equals the opposite over the hypotenuse, x to 15. I picture that as a proportion and I cross multiply. So x equals 15 times sine 28.0725. So let me type that in. So 15 times sine 28.0725. Okay, and that gets me about 7.0588. So I've been training my calculator to round to 4 decimal spots. Okay, and this I'm building off of a rounded intermediate step. If you kept it nice and precise in your calculator and built along the way, you could get a slightly more precise answer. Both of those are fine by me. All right, next up. So here we have all the skills to do this problem. We just haven't ever seen it presented this way. So here we're told a sine ratio, and from here we want to build and figure out what is the cosine ratio for the same reference angle. So if I'm given sine, I know that sine is opposite over hypotenuse. So let me make myself a picture. So from x, my opposite is 21, and my hypotenuse is 29. Right? I'm never drawing this to scale because I don't really know what the scale is going to be yet until I'm done with the problem. So I have my opposite side and my hypotenuse. Now when I look at this as a right triangle, I recognize that it's a common triple. And that common triple is 20, 21, 29. So I can see, what are we missing? We're missing the 20 right here. Okay, so in relation to where x is, right, here is my adjacent side, here is my opposite side, here is my hypotenuse. So if I want cosine, I know that cosine x would be the adjacent to the hypotenuse, and that would give me 20 to 29. So cosine x would be a ratio of 20 to 29. All right, let's look at 4. 4 is going to be very similar. Here I'm giving you tangent x. So tangent we know is opposite over adjacent. So let's make ourselves a picture here. Here is where x is, so the opposite is 3 and the adjacent is 5. Okay, this is not a common triple anymore. I need to solve for that missing side, and it's my hypotenuse. So I could use Pythagorean theorem, or I could take that little shortcut that says, well, my hypotenuse is always the square root of 3 squared plus 5 squared, right? The legs squared and added together. So now I'm looking at the square root of 9 plus 25, which is 34. Okay, there's no pair in 34, so that missing side right here is just root 34. So now, in relation to x, here is my adjacent side, here is my opposite, here is my hypotenuse. So if I want sine, right, I want sine x. Well, that's my opposite to hypotenuse. So that would be 3 to root 34. And then I need to rationalize. We don't leave a root in the bottom. So I multiply by root 34 over root 34. And I end up with 3 root 34 divided by 34. It does not reduce further. That's as simplified as I'm going to get. All right, next up in number 5. So a couple word problems. The angle of depression from the top of a 200-foot vertical cliff to a boat is 32 degrees. Find how far the boat is from the base of the cliff. Okay, so we've got some sort of cliff over here. And we've got a boat in the water, right? So I always draw mine as a little sailboat. Not sure why, but it's what I like. So there we go. I know there's a right triangle in all of this, so let me kind of sketch it out like so. And now I need to add in the details. So angle of depression from the top of a 200-foot vertical cliff. So angle of depression, I got to picture that horizontal pathway from the top of the cliff looking down towards the boat. So that angle of depression is 32 degrees right here. Now, I need to get inside of my triangle. So there's 2 angles I could connect to. I could look at the angle of elevation right here. These would be alternate interior angles. So I'd have a 32 degree measure right here. I could have also connected to the complement of 32 right here and marked this angle as 58. That would have been fine also. Just mark that right angle right there. Either of those is fine. Okay, what am I ultimately solving for? I want to find how far the boat is from the base of the cliff. So I want X right there. So depending on which angle you make your reference angle, let's say that I make it this one. In relation to 32, I have an opposite and an adjacent side. So what am I going to use? I'm going to use tangent. So I can say that tangent 32 equals 200 to x. Okay, there's my proportion. Cross multiply. So x times tangent 32 equals 200. And then from here, I'm going to divide away the tangent 32. And then what do I end up with? I end up with 320.0669 feet. All right, so I wanted to give you a little bit more practice with what happens when I give you an angle of depression. All right, number 6. We've seen this problem before, but I wanted to make sure that we know how to do it because I saw some questions in the homework. Okay, so suppose a ladder is safe if the angle it makes with the ground is from 60 to 80 degrees. Okay, well, let's visualize that. Right, we have two extremes. I could have right here where this is 60 degrees, and here's my ladder. Or it could be like this, where this is 80 degrees, and here's my ladder. All right, so we're told our safety restrictions. We're told, okay, it's safe if the angle it makes with the ground is from 60 to 80 degrees. So anything in between these two extremes is safe. Now, how far up on a vertical wall can a 30-foot ladder of this type reach? So it's saying essentially find the maximum vertical height. The ladder is 30 in both instances, but in which scenario will I get a maximum vertical height? Well, it should be this one right here, the one where the angle is 80 degrees. This would be the x that I need to solve for. Right, I'm going to remind you that opposite a larger angle is a larger side. So the maximum vertical height will come from over here. So in relation to where 80 is, I have an opposite and a hypotenuse. So I'm going to use sine. I know that sine 80 equals x over 30. Okay, cross multiply. And x equals 30 times sine 80, and we end up with about 29.5442, and my units are feet. All right, we should be good to there. Let's do a little flip, and we have 4 problems on the back. All right, so for example 7. In the triangle shown below, the measure of angle A is x minus 20. Okay, let's add that. Here's x minus 20 degrees. We want the measure of B. Okay, so if this is 90 degrees right where T is, then we know that A and B, they have to be complementary. They are complements. So angles A and B are complementary. Right? They're going to add to 90 degrees. So if I make that a sentence, right, I could say, well, as an equation, the measure of A plus the measure of B would have to add to 90 degrees. All right, well, I know the measure of A is x minus 20, so I can swap that in, x minus 20 plus the measure of B equals 90. Okay, but my instruction is to solve for measure A. Find the measure of angle, angle B, sorry. Find the measure of angle B. Let me go back and show you. Find the measure of angle B, right there. Okay, so I want to solve for the measure of B. So I'm going to go ahead and I'm going to take away x from both sides. And I'm going to add 20 to both sides also. So the measure of angle B then would end up being 110 take away x. So 110 take away x degrees. So I can't get any closer than that. That's the best that I can do, but that's fine. I'm just leaving it as an expression, 110 degrees, but take away whatever x is. All right, next up, 8. Find the area of the segment. Okay, we did this in our last unit. Round all intermediate steps to the nearest 10,000th. Plug in for pi. Okay. So I know that a segment is always the sector minus the triangle, but I need to know the base and the height of the triangle, and I need the radius if I'm going to calculate the sector. I know neither of those things right now. So right now what I can see is I have this triangle. Let me rotate it and draw it a little bit clearer like this, where this is the 100 degrees right at the tippy top like that. And I know that this whole span here is 10, right? That is given to me. Now, I can see that this triangle is isosceles because if I connect the center to a point on the circle, that's a radius. Center to a point on the circle, that's a radius. So I can split this isosceles triangle right down the middle and make this angle 50 and this angle 50. And then if this whole span is 10, this is 5 and this is 5. And now I know what to do from here. Let's say that I call this part x. That would be the height of the triangle. And this part y. That would be the radius of the circle. Let me just draw one of those two right triangles out to the side just to see things even more clearly. So this is 5, this is x, and this is y. Okay, so if I want to solve for x, so from where 50 is, right here, I have an opposite, an adjacent, and a hypotenuse. So if I want to get to x first, I know that tangent 50 equals 5 over x. I'm going to visualize it as a proportion and cross multiply. So x times tangent 50 equals 5. Divide away the tangent 50. And we get that x is about 4.1955. So that's right here. That's x. That's the height of the triangle. If I draw it in right here, I can label it. So right there is about 4.1955. That's the height of the triangle. Okay, if I want to get to the radius here, the y, I would use sine, opposite hypotenuse. So I know that sine 50 equals 5 over y. Okay, there I'm visualizing it as a proportion, and then I cross multiply. So y times sine 50 equals 5. Divide each side by sine 50. So y is about 6.5270. I'm just writing the 0 so you can see it as a placeholder for that fourth position. Okay, Okay, that's my radius. So let me add it to my picture. That's 6.527. 6.527. Okay, so I'm recording all of my intermediate steps to the nearest 10,000th, right? 4 decimal spots. So now I have to keep going. Let me zoom out a little bit so I can see the whole picture. All right, so I know that I'm going to get the sector, and then I'm going to take out the triangle. So my segment is always sector minus the triangle. So my sector, I'm looking at the ratio of sector to circle. So 100 to 360. Okay, times pi times my radius, 6.527 squared. Okay, my triangle will be half the base times the height. So half of 10 times 4.1955. All right, so let's make sure that we can plug all that in correctly. So right here, this first part on the left. So I'm looking at 100 divided by 360 times pi. So for this calculator, second and caret, there's my pi. I'm plugging in for pi. This is one of the only times I let you plug in for pi. On one of these scientific calculators, right here, pi is right here. So here's where you would plug in for pi, right there, right here. I'll show you with my finger, right there. Okay, so now I'm going to also multiply that by 6.527 to the second power, just like that. So that's how that types in. So I get about 37.177. So 37.177, okay, units are squared, we know that. And that is, again, building off of the rounded intermediate steps. Okay, for the triangle, here I'm multiplying across half of 10 times 4.1955. So here I get about 20.9775. All right, so then I have to subtract the 2. So if I take my 37.177 and I remove the 20.9775, that's going to get me about 16.1995, and my units are squared. So again, that's building off of rounded intermediate steps. I've rounded to 4 decimal spots. If I had kept everything in its original format in the calculator and I didn't round until the very end, that would have given me about 16.1999 units squared. This would have been the more precise answer right here. But again, it doesn't matter to me. These are both close enough. They're very close anyways. All right, two more word problems. Okay, so I wanted to revisit this style of problem one more time. So we have 2 friends. They're on the same side of a 12-foot fence, and they notice the angle of elevation to the top of the fence as 52 and 80 degrees respectively. We want the distance between the 2 men. So let's say that I put my fence right over here. And I put the first friend, let's put him here, and the second one here. Doesn't matter who I call A and B. Here's the horizontal distance for both of them to the fence. And we're told angle of elevation. So if friend A is looking to the top of the fence, that is friend A's angle of elevation. And for B, same thing. All right, so here's my bones of the problem. What is it I ultimately want to solve for? I'm solving for the distance between the 2 friends. So I want right here, I want the distance from friend B to A. That's what I want. So when I fill in my other information, I know that the fence is 12 feet. Here's a little right angle, trigonometry, all about the right triangles anyways. All right, we have 2 angles of elevation. So which one is which? We have one that's 52 and one that's 80 degrees. So the one that's further away, that's our smaller angle. So 52 would be here, and then 80 would be right here. Okay, so what can I solve for? Well, I can solve for any side of a right triangle if I know one of the two acute angles. So I can solve for this span here, I'll call it x, and I can solve for this span here, I'll call it y. And then ultimately, if I want the distance from friend B to A, that's really going to be the difference between the two. We want x minus y in the end. All right, to help you see this more clearly, I'm going to visualize the two separate triangles. Right, the bigger one right here, here's the 52, here's the 12, here's the x, and for this one right here, here's the 80, here's the 12, and here's the y. Okay, so I have the legs marked, which means I'm using tangent. So from 52, I would say, well, tangent 52 equals 12 to x, and over here, tangent 80 equals 12 to y. So I need to solve for x and for y, and then take the difference between them. So here, if I cross multiply, x times tangent 52 equals 12. Divide away the tangent 52. All right, and then what do we get overall? 4 spots, we get 9.3754. There we go. All right, how about the y? So here again, visualize it as a proportion, cross multiply. So y times tangent 80 equals 12. Divide away the tangent 80. Okay, when I divide 12 divided by tangent 80, that gets me y is about 2.1159. So remember that overall, we are taking the difference between the two. This span is 9.3754 units. This one here is 2.1159. So when I subtract the two, I end up with 7.2595, and my units are feet. Okay, one more problem. All right, we got Marcy. She's holding a kite string in her hand that's 58 feet long. The angle of elevation from her eye line is 44 degrees. The distance from the ground to her eye line is 4.75 feet. How high is the kite above the ground? Okay, so what do we got here? We have Marcy playing with a kite. Let me give her a little hair flip. Give her a little skirt as well. She's got a kite in the air. So let's put the kite maybe here. And I'll have the string attached, something like that. All right, I know it's a right triangle problem, so it's got to be here and here for the right triangle. Now let me add my details. So the string, 58 feet long. So from Marcy to the kite is 58 feet long. The angle of elevation from her eyes, right, always from that horizontal, is 44 degrees. Okay, let's see. The distance from the ground to her eye line is 4.75 feet. So I have to add in that detail right there. Ultimately, I want how high the kite is above the ground. So I can solve for this part. I could call that x, but ultimately, my total height above ground will be x plus 4.75. So I'm just keeping my eye on the prize, right? What is it I'm ultimately trying to get to? All right, let's get to x. So from the 44 degrees right here, I have an opposite and a hypotenuse. So I'm going to use sine. So I have to say that sine 44 is equal to x over 58, opposite over hypotenuse. Visualize it as a proportion and cross multiply. So x equals 58 times sine 44. I end up with x at about 40.2902. All right, so that's the span from the kite to where Marcy's eye line would extend to. So we have to make sure that we tag on that little extra of 4.75. So add the 4.75, okay, and we get a grand total of about 45.0402. And my units are feet. All right, that's all I have for today. Have a good rest of your day.